Welcome to P002, our second physics lesson. In the previous lesson we learned about units and dimensions, the language of measurement. Now we are going to use that foundation to study something we experience every single day, motion. But motion in physics is more subtle than it seems. There is a crucial difference between how far you travel and how far you actually are from where you started. And the direction of movement matters enormously. By the end of this lesson, you will understand the four most fundamental quantities in kinematics: distance, displacement, speed, and velocity. Let me start with a story. Imagine you are running on a standard 400-meter athletics track. You run one complete lap and stop exactly where you started. Now here is the question: how far did you move? If you answer 400 meters, you are thinking about distance, the total path you covered. But if someone asks where are you relative to where you started, the answer is, you are right here. You have not moved at all. Your displacement is zero. This is not a trick. This is a fundamental distinction in physics. Distance is the total length of the path you travel, regardless of direction. Displacement is the straight line difference between your start point and your end point, and it has a direction. One of them is a scalar quantity, and one is a vector. Understanding this difference is the foundation of kinematics. Before we go further, we need to understand the difference between scalar and vector quantities. A scalar quantity has only a magnitude, a size. Distance is a scalar. If I say I walked 5 kilometers, that is complete information. You do not need to know which direction. Speed is also a scalar. Temperature, mass, and energy are all scalars. A vector quantity has both a magnitude and a direction. Displacement is a vector. If I say I move 5 kilometers north, the direction north is essential to the meaning. Velocity, acceleration, force, and momentum are all vectors. This distinction is not just terminology. Scalars and vectors obey different mathematical rules. You can add two displacements that point in opposite directions and get zero. But you cannot add two distances and get zero. Understanding which quantities are scalars and which are vectors is essential for solving every mechanics problem correctly. Now let us compare distance and displacement directly. Distance is the total length of the path you travel. It is always positive because you are always covering ground in some direction. Displacement is the straight line distance from your starting point to your ending point, measured in a specific direction. Displacement can be zero even if you have moved a lot, like our running track example. Displacement can also be negative, which simply means you ended up behind where you started, depending on how you define the positive direction. Both are measured in meters. The important thing to remember is this: distance is about the journey, displacement is about the result. A student walking from home to school and back home again has covered a total distance of, say, 2 kilometers, but their displacement is zero because they are back where they started. Speed and velocity have the same relationship as distance and displacement. Speed is the rate at which distance is covered, it is distance divided by time. Velocity is the rate of change of displacement, it is displacement divided by time. Speed is a scalar. Velocity is a vector. Here is a practical example. If a car travels 60 kilometers east in 1 hour, its speed is 60 kilometers per hour and its velocity is 60 kilometers per hour east. The direction east is part of the velocity. Now here is something important. If an object moves in a circle at constant speed, its velocity is constantly changing even though its speed is not, because the direction is always changing. This is why circular motion involves acceleration even when the speed is constant. Also notice, average velocity can be zero even if the average speed is not. If you drive 100 kilometers to a city and 100 kilometers back in 2 hours total, your average speed is 100 kilometers per hour but your average velocity is zero. Now we come to the three equations of motion. These are among the most important equations in all of Class 11 physics, and you will use them in almost every kinematics problem. They are valid only when acceleration is constant throughout the motion. The first equation says final velocity equals initial velocity plus acceleration multiplied by time. This is essentially the definition of constant acceleration. The second equation gives you the displacement. It equals initial velocity times time plus half of acceleration times time squared. A half comes from the calculus integration of velocity. The third equation is the most elegant. Final velocity squared equals initial velocity squared plus twice the acceleration times displacement. This one is incredibly useful because it does not involve time at all. Whenever a problem gives you velocity and displacement but no time, this is the equation to use. Together, these three equations can solve any constant acceleration problem. Here are your NET exam tips for this topic. Free fall problems are the most common application of equations of motion. A ball dropped from a height or thrown upward with some initial velocity, these appear in almost every NET physics paper. For a ball thrown upward, the moment it reaches maximum height, its velocity is 0. Use v equals u plus it to find the time to reach maximum height, or use v squared equals u squared plus 2 as to find the height directly. For average velocity, remember that the formula u plus v divided by 2 only works when acceleration is constant. Do not apply it to problems involving changing acceleration. And the most reliable check, if a problem tells you that distance equals displacement in magnitude, it means the object moved in one direction only without turning back. If displacement is less than distance, the object changed direction at some point. This fact alone can eliminate wrong answer choices quickly. Let us summarize what you learned today. Distance is a scalar, it is the total path length and is always positive. Displacement is a vector, it is the straight line change in position and can be 0 or negative. Speed is distance divided by time, a scalar. Velocity is displacement divided by time, a vector. Velocity can be 0 even if you have been moving, if you return to your starting point. The three equations of motion, v equals u plus it, s equals ut plus half it squared, and v squared equals u squared plus 2 as, are the core tools for solving constant acceleration problems. And for free fall, acceleration is 10 meters per second squared downward, and at maximum height the velocity is exactly 0. In the next lesson, P003, we will look at acceleration in more depth, draw and interpret graphs of motion, and tackle projectile motion. See you there.